CT scan. And basically, in X-ray, we discussed that X-ray is like one dimensional. So it only covers one dimension. And let's suppose if we want to diagnose, or if we want to discover more sides, more angles, so we can use this CT scan method to get images from different angles, or in simple words, we can say it will give you 3D X-ray. And you normally observe the practical picture of the CT scan. There is a like a circular hole in the center, and in that circular part there is a bed which is movable, and that moves into the circle or out of the circle. And that in that whole circle, we have whole setup of CT scan. There is magnetic electric field contained in that CT scan machine that passes and generates X-rays from different angles.
Okay, so it's like multiple viewpoints and then they like combine it to make the whole like final image.
Yes, for example, if there is a source on one end, so it receives on the other end, then it starts to rotate, for example like this, and then we will get output from this angle. So in the same way we can like get pictures from all different angles, and this will give you a complete 3D X-ray in short, right?
Okay.
Yes, and mostly in questions they ask about the working in exam, just like this is for 4 marks. Outline briefly the principles of CT scanning. In the same way, this is for ultrasound, CT scanning for 6 marks. So maximum you will get this question for total 6 marks. So
Okay. So
yeah.
like how would we answer like what would be the 6 points which I would have to write?
Okay. So first of all, the first point, as we already discussed, that we can take X-rays from the different angles. So this is the first point, the part of the body to be analyzed is divided into,
Multiple images or like
yes, smaller parts called voxels. And this topic is included in old syllabus like till 2022. And there are like numbers or calculations also included with this topic of voxels to calculate and identify the numbers. But in new syllabus update
but
after 2022, we don't need to practice any numbers or any questions related to this voxels concept.
okay, that's nice.
Yes. So that's why in new questions you observe, we are getting question completely for 6 marks. And this is a complete question. You can see only one question, no other parts, total for 6 marks.
Kind of more like how a bio
Yes.
question.
And second point is each voxel has a particular absorption.
Wouldn't they be equal or no?
Basically, it depends upon their absorption intensity. It
Oh,
depends upon, because we know that there are different parts of the body, and it depends upon, just like if they are scanning the brain or if they are scanning different parts. So it depends upon the intensity, that how much intensity is required to scan that part, right? Because some parts are sensitive, so it is not good to transfer very high intensity X-ray through that part. So it depends upon that specific condition.
Okay.
Like if we are taking a CT scan for a solid uh, side of the body, just like shoulder, elbow, like this, so we know that it is made up of strong bones, so we can make X-ray from strong intensity. But let's suppose if we are taking CT scan of the brain, so in that part we know there is no bones in the brain, so definitely we required less intensity.
Okay.
Particular absorption intensity of X-ray called a pixel. Third point, as we discussed that X-rays can be travel from different angles. So X-rays are sent from different angles, to that specific part, and a two-dimensional X-ray image is produced in the computer. So in three steps, we discussed that we got 2D image, right? And we know that it will give you a 3D image. So the fourth point is this procedure is repeated from different angle, from different angle, and the images formed are joined. Images formed are joined.
To like form one composite image.
Yes, to form a 3D image. To form a 3D image. And right now we got the complete answer, right? So definitely now this process repeat for different voxels also. So this can be viewed from different angles.
So like this 3D image can be viewed from.
Yes, just like if you consider the example of the surface of the football. So football is completely sphere, but still you can rotate, you can take observation from any point of that football. So in the same way, you can rotate or that 3D image to observe from different angle.
Okay.
Like in our diagram, we only mark horizontal and vertical. So this is only two possibilities. So you can also rotate it, or you can also move it from the fixed point or any reference point. So you will get different angles, different diagrams from different angles also. And it also captures that image.
Okay.
Like after CT scan, you will get complete images just like the X-rays, photographic plates. And secondly, there is also like recorded DVD or like data also included in the computer that gives you the complete movement and the complete film of that CT scan process, right?
Right.
So the same procedure is followed for all other voxels.
So this is like the 6 marks.
Yes, because in our syllabus there is no like advanced detail included. So maximum, you can also check marking schemes. So sometimes they ask for 6 marks, but like this is from 2016, and basically new papers mostly we will get for less marks because they used to ask a calculation based question or more conceptual question, because this is like a copy paste question. So this is simple, right?
Right, right.
But let's suppose if you get for maximum 6 marks, so by using this point, you will get complete 6 marks, right?
Okay. That's good to know.
Because all points gives you different idea. We know that process is very simple. We just need to take pictures from different angle in simple words. But we use the word pixel, voxels, 2D image first, then 3D image, then we can observe that 3D image from different angle. So definitely these points are different from each other, right?
Right.
So this is for a CT scan, and this is the easiest one. And secondly, right now we are not talking about the values and the calculation. So in your past papers, like in old papers, you can see this is related to creates a model of CT scan, and section is divided into four voxels, right? So you can see this is from 2017. So this type of questions are not included now in new syllabus. Okay.
Okay.
Okay. And if we consider some advantages and disadvantages also, for example, if we talk about advantages, so definitely we are getting 3D output from this process. So it produces very fine images, as compared to ultrasound. Secondly, it is also reliable, and it allows to study dense structures. Like in practical life, did you observe any result of CT scan practically?
I I haven't had one.
Okay.
Like
Because
you
if
can
you
use it to
observe
like diagnose
in
stuff. Like
yes,
in movies or like shows, you can see like people go inside like
yes.
the tube.
So practically when we got output, so we got output from different angles like this. It depends upon the scan, what type of a scan they are using. So we will get in different angles pictures like this.
Okay.
And if we consider disadvantages,
Would it be like carcinogen?
yes. First of all, it is costly, and it also takes time. Like in a deep CT scan, it takes almost 40 to 45 minutes. So it takes time.
Oh, right. It's very
Y-
long.
If there is a deep scan, if normal scan also takes like 15 to 20 minutes, and it is also not portable. We required a complete room for the setup of this CT scan. And
Does
also,
it also get very hot? Like it releases a lot of energy and stuff.
yes. And we can also say it is not efficient, like it wastes very high amount of power.
Right, because like it spends a lot of energy.
Yes. And definitely it requires a trained person to operate it. Training is required. So these are some advantages and disadvantages if they ask in some questions. So you can write these points. Okay, after this, we have like the third possibility for scanning, that is ultrasound. Normally, we know that it is the sound wave having frequency greater than 20,000 hertz.
Okay.
Because in IGCSE, we studied this topic and we only study basic information that it is a sound wave with frequency greater than 20,000 hertz. Because within 20,000 hertz, human ear can easily hear the sound between 20 to 20,000
Right, like we can hear 20 to 20, like 20 to 200, 20
thousand hertz.
hertz,
Yes,
right? 20 hertz to 20,000 hertz.
yes. And if we increase, so that is not audible.
Is this safe? Like ultrasounds? Because there's no like lead, like people don't wear like lead and stuff for this.
It is more safer than X-rays and CT scans, etc. Because
Okay.
it consists of sound waves, not like electromagnetic waves.
Oh, right.
So
Got it.
less penetration power, and we can use it for soft parts and soft tissues to scan that specific area.
Okay. Also, what was I thinking? Right, do I have to memorize all of these like the frequencies and stuff? Because I kind of forgot them from O levels.
Basically, right now we only discuss about X-rays, that is from 10 to the power minus 8 to 10 to the power minus 6. That is the only range. And right now we are only talking about ultrasound. Other than that, there is no frequency, no wavelength we need to learn for any calculation.
Okay.
Yes. And the setup for this ultrasound, like how it produces and what are the components we are using. So we simply use, let's suppose, two silver plates If we talk about the generation, that how it starts to generate. So on one side we are using,
Is there cathode and anode in this as well?
yes, so we are using positive negative terminal again, and these are silver electrodes.
Okay.
Because resistivity of silver is less, so we can easily conduct electricity through it. That's why we are using silver.
Okay.
And in the center, we are using quartz material.
Oh, like those stones.
Yes, because it helps to vibrate particles easily. So that's why we are using,
Quartz.
yes. In watches, we also use this material because it helps to vibrate or oscillate to and fro easily.
Oh, okay.
Yes, because it only takes for 1 second and we required a specific vibration after a specific interval of time. So that's why this material helps. Or in other words, we can say it is piezoelectric material.
How do you spell that? Okay, piezoelectric.
Yes. So basically there are two names. So normally we use piezoelectric in our syllabus, or in simple words, it is called quartz.
Okay.
Yes. So basically in this whole scenario, setup is very simple, just like the X-rays one we discussed. So first of all, a quartz or a piezoelectric is sandwiched between the two silver electrodes and alternating voltage is applied across it. Because just like a CT scan, you will get questions for the ultrasound questions for detailed question, 4 marks, 5 marks, 6 marks question like this. For 4 marks, principle of generation, like how to generate it. So we are talking about the same thing, generation of ultrasound, that how it actually generates.
Okay.
So according to the setup, this piezoelectric material is sandwiched between two silver electrodes, and an alternating voltage is applied across it. And why we are using alternating voltage? Because as we discussed that this material helps to vibrate. So let's suppose if we are using positive on left hand side, negative on the right hand side, and then in alternating voltage, we know after every half cycle it changes the direction, changes the polarity. So for example, if we are using positive on left side and negative on the right side, like this. So in this scenario, let's suppose we are getting compression, like material
O-
particles comes close together. So we got compression. And when the direction changes, like negative on the left side, positive on the right side, so it expands. So in this way, it starts to vibrate. So this is the reason we are using alternating voltage. Otherwise, we can use a DC voltage also if we only required positive and negative charge, right?
Okay.
And the second point, The quartz or quartz crystal is cut into a certain shape and size such that
It perfectly fits or what?
basically it depends upon the natural frequency factor. Maybe if you studied oscillation chapter in detail, so there is a concept of damping over there,
Yeah, yeah, yeah.
like in bridges and all these construction buildings and all these things, we use a certain
Like
elasticity.
the resonance, I think.
Yes, because if a normal frequency of the object matches with the natural frequency in the surrounding, so it causes resonance because it
Yeah.
increases the frequency or the vibration of that body and it starts to deform because of greater amplitude. So that's why we need to use crystal according to that certain shape or size that it natural frequencies lies within the ultrasonic range. Otherwise, it matches with the other range and it collapse.
And it okay, so like it would be too much for it to withstand.
Yes, ultrasonic range. Third one, as we already discussed, that due to alternating voltage, the crystal resonates and produces an the crystal
Resonates and produces.
ultrasound waves. Because we uses such type of shape and size that it lies within the ultrasonic range, so definitely it will not reaches that ultrasonic range, it will remains in the ultrasound range
Okay.
and produces in air. So basically this is the main purpose, or this is the process that how we generate these ultrasound waves.
Okay.
And second idea is that how to detect it.
The ultrasound, how to detect the ultrasound?
Yes, basically, like if we want to detect, like in CT scan, we know that X-rays are moving from one end, and on the other end, we have that receiver to receive it.
Okay, so for this, they would also have like a receiver and all.
Yes, because right now we only mentioned that how to generate it, and
Okay.
from let's suppose the fourth point we can say that is related to the detection of it, the piezoelectric transducer, which was used as a transmitter. And if you remember that concept of echo, we studied in IGCSE also, that we can
Yeah.
find out the speed of sound by using the method of echo also. Like if we are standing 50-meter away from the wall and if we generate sound, so sound first travel 50 meters in forward direction. So we are the source, we are generating sound. and when it hits the wall and moves in the opposite direction, so we are the single receiver, and we are also the receiver of that sound. So we are the source and we are the receiver. So in the same way, initially piezoelectric is generating that ultrasound waves, and now after it strikes the other surface and bounce back in the opposite direction, so this material also acts like a receiver.
Okay.
So it is now acting as receiver, because in diagram there is no other material we are using. So the same material generates and same material receives it. Just like we discussed in the examples of sonar and radar system, sound waves generate and it strikes the other material and it comes back, and then we got identification. And we discussed about compression and rarefaction part. So the compression and rarefactions of reflected ultrasound are picked up by the transducer and crystal oscillates and induces opposite charges on the plates, just like we discussed positive to negative, negative to positive. And then the remaining 2 points, this alternating voltage signal now induced is sent to the computer. After amplification, because with the help of amplification we got a greater amplitude, so it will be easy to read the signals. And last point, the time of return and angle of return is used to detect the internal structure.
So they see it's kind of like how like I don't know where I read this, but like there used to be boats which would be used in war, so I think they'd use like the sound effects to like locate where like other ships or like objects would be.
Yes, so radar and sonar system, they also works on the same principle with the help of a sound effect reflection of the sound waves, right?
So this is